So, you've chosen the Anvil, assuming you don't want to kill the bear, but only knock it out. We would need to calculate how high to drop it. If the average hiking anvil weighs about 50 kilograms, and the bear looks like a 450 kilogram Ursus arctos, how would you calculate this? Firstly, find results from a real experiment on live subjects that match your perception of a knockout. Secondly, convert experimental data to max intracranial pressure. This is so that varying brain sizes from different animals can be accounted for. Thirdly, create a mathematical model of how the brain interacts with the skull. This will allow us to observe the effects of different spineward impact velocities. And finally, code the Euler integration equivalent of the model and iterate through impact velocities while recording peak intracranial pressures. Once the pressure from the model is greater than that of the experiment, we will have our required impact velocity, which can then be used to calculate the knockout drop height. But firstly, what is a knockout? In essence, a knockout is the brain shutting down from too much movement. There's a lot of science behind this, such as imbalanced electrolytes and brainstem torsion, but the main factor is brain into skull fast. As to how fast? We can reference these experimental results from 1959, back when NASA tested survivability on living subjects. The result most like a perception of a knockout is when a hog was accelerated at an onset of 13,000 Gs per second to a peak acceleration of 160 Gs. Modeling the experiment and accounting for the size of the hog's brain and skull, we get a maximum intracranial pressure of 51 kilopascals. This knocked out the hog for about 10 minutes. For those of you concerned with the hog's quality of life after the experiment, they later confirmed the hog to be perfectly healthy in an autopsy. Before we start our calculations, let's assume the anvil will hit the bear at the top of its head. We also need to collect some constants such as skull mass, a neck stiffness coefficient, and the Young's modulus of skin. It's hard to find the stiffness values of a bear, so to approximate the coefficients, we will need to cross-reference a human head and adapt the coefficients from a research paper analyzing head impacts with footballs. By modeling bear in the same way and running some stress simulations, we ballpark some coefficients. Now for the actual calculations. Since our target is the intracranial pressure of 51 kilopascals, we focus on the motion of the brain. Using Euler integration to analyze each of the equations of motion, we iterate on the anvil's impact velocity until the max pressure matches our target. And thus the anvil needs to be going 8.2 meters per second, or a drop from about 3.4 meters. You now have all the information you need to protect yourself via an anvil drone. Thank you for choosing option E.